On the first session of the sixth day of the FDP. I'm excited to get this opportunity to introduce our speaker, Dr. Shraddha Porwal. Shraddha Porwal is Assistant Professor in JP Institute of Information Technology, Noida. Her area of research interest include cryptography, network security, data structure, and algorithm. She has published several papers in international journals and conferences. She has one granted patent and four published patents. She earned her PhD from JP Institute of Information Technology and MTech from Maulana Azad National Institute of Technology, Bhopal, India. She has more than 13 years of teaching experience. She has published two technical books and one poetry book. She is a member of ACM. Today, she will give us insights about the blockchain for cybersecurity. We all are eager to hear from you, ma'am. You may please start the session.
Good morning, everyone. Myself Shardha Porwal, and today I am going to present on CPAB and blockchain technology. Okay, so
Shraddha ma'am, your screen is not shared with us.
okay, ma'am. Ma'am, screen is visible.
Yes, ma'am, it is visible now.
Okay, so my title. Okay, actually, this is because of LibreOffice. Okay, no issue. My title of presentation is Ciphertext Policy Attribute-Based Encryption Algorithms for Secure Communication via Blockchain. And as we all know, that blockchain is in blockchain electronic documents are stored basically there, so and these documents are visible for everyone to view. It is essential aspects in many cases, but it is difficult, it is a liability in sensitive environment. Okay, so this technology is very demanding technology and still has to go a long way to be adopted on a very broad scale. So there is need to be remodeled in a way that allow restricted access and is accessible only to people who are authorized to view it, such as in banking system. And there are some documents that should be accessible to the person connected to the network. Okay, in that case, there is a requirement of privacy and security. Normally data is stored in such a way. This is the diagram. There may be any kind of document, there may be video, audio, data, photos. Okay, data is encrypted and hash after performing the hash and adding the timestamp, it is stored on the blockchain. So the issues that exist with blockchain technology are data privacy leakage, unauthorized access, supervision, trust issues. Protection of privacy of shared data has become a key factor, and it is restricting the implementation of this technology on broad scale. So for privacy, we should add basically encryption algorithms to make it more applicable or to make it secure from privacy issues. Okay, so there are basically two symmetric algorithm. One is symmetric key cryptographic algorithm, and other is asymmetric key cryptographic algorithm. In symmetric key cryptographic, there is public private key encryption algorithm. There is same key is used for encryption and decryption, while in public key cryptography, each, each user has two keys. One is user public key, another one is user private key. Public key is used for encryption, and private users private key is used for decryption. Okay, so this conventional public key cryptography is one-to-one encryption. So if we have to share a document to n users, we have to perform n encryption operation, and n ciphertext will be generated. Here we for n users, the total number of keys will be 2n, and number of ciphertext will be generated. Number of n ciphertext will be generated. Another advanced version of public key cryptography is attribute-based encryption system. In this system, there is a common global public key, and uh, each user has their private key. So to share a data, we have to perform only single encryption operation, and depending on the requirement, individual user can decrypt the data from their private key. So the total number of keys here are n plus 1. One is global public key, and n different private keys of different user, and number of only one ciphertext is generated. So AB is one-to-many encryption technique. In this technique, each user possesses certain set of attributes based on their roles in the environment. There are basically two keys. One is global public key, that is common for every user. Another one is the private key, and this key is generated by a central authority in the system. Global public key is used for encryption, and private keys of user are used for decryption. So this is a comparative analysis based on the storage and functionality requirement, that is function of encryption and decryption. So in symmetric key, to perform n cross n communication in symmetric cryptography, we require n into n minus 1 by 2 keys, while in public key cryptography such as DSA, we require 2n keys because each user has 2 keys. And in attribute based encryption, we require only n plus 1 keys. In symmetric key cryptography, n minus 1 ciphertext will be generated. In public key cryptography, n minus 1 ciphertext will be generated, while in attribute based encryption, only one ciphertext will be generated. So it increases the efficiency in terms of storage and computational cost. So AB is divided into two parts. One is CPAB, another one is KPAB. CPAB is ciphertext policy attribute based encryption, and KPAB is key policy attribute based encryption. The difference is basically it depends on access policy generated by the access policy generated at the time of encryption, or it generated by the central authority. This is the main difference in KPAB and CPAB. In KPAB, central authority generates the access policy, while in CPAB, data owner generates the access policy. So here, owner has rights to specify the users of his or data. Okay, so in KPAB, users key are attached with the access policy, while in CPAB, ciphertext is attached with the access policy. In KPAB, each user's key is generated, and access policy is generated at the time of key generation, while in CPAB, access policy is generated at the time of encryption. KPAB is useful in centrally controlled environment, while CPAB is useful in collaborative work environment. So based on the utility, CPAB is more applicable. I am showing the work on CPAB only. So we can understand the system of CPAB. There are mainly four entities: central authority, data owner, data users, and central data storage, or it may be local storage server, or it may be a cloud, anything. Okay, so here basically the role of central authority is to perform setup operation and key generation operation. Setup operation, it generates global public key and master secret key. Global public key is used for encryption, and master secret key is secret for this central authority. This master secret key is used for generating the keys of different users. Okay, so in setup operation, it generates global public key and master secret key, and then it's perform key generation operation to generate the key for different users based on their set of attributes. Here GPK is global public key, MSK is master secret key, and S is set of attributes, and it generates the private key for different users based on the set of attributes. And data owner, as in CPAB, ciphertext access policy is attached with the ciphertext. So data owner decide the access policy. Here I have taken the example of an university document that should be accessible by only VC, Dean, or VC or Dean, or HOD, or HOD of CSE IT department. So here there are two attributes, HOD and CS department. So if it both attributes should be satisfied, that's why we have used AND gate here, and one of three, it should be either BC or Dean or this. Okay, so to encrypt the data, we require global public key. M is the data or message, and T is the access policy. At the time of encryption, we attach the access policy, and generated ciphertext is stored on the central data storage. To decrypt the data or to access the data, user need to satisfy the access policy based on the set of attributes. So suppose this is user 1, its attribute is VC, it satisfy the access policy, so it will decrypt the data using his or private key. Okay, so again another user is Dean, it will be able to access the data because it is satisfying the access policy using the private key. And next is registrar, because this is not able to access the satisfy the access policy and will not be able to decrypt the data. What should I do? Ma'am, actually it's, I think it's not visible correctly, na?
Yes, ma'am, it is not visible.
Ma'am, I am connecting with my laptop. Okay.
So, okay.
So basically, we can combine this blockchain technology with CBE here before storing the document on the blockchain. Document should be encrypted using CPAB encryption via public key generated by the central authority. W is the access policy and M is the data, and CTW ciphertext based on the access policy will be generated. To decrypt, to access the data, data accessed through the blockchain should be decrypted via decryption procedure of CPAB. Okay, and here SK is basically secret key of the user generated by the central authority, and CTW is the ciphertext, and SK is the set of attributes that is required for satisfying the access policy. PK is the private key. So basically, the components that is required to implement the ciphertext policy attribute-based encryption technology are policy expression, access policy, length of the ciphertext, and architecture. Policy may be monotonic and non-monotonic. In monotonic access policy, in the access policy, only positive attributes can be added, while in non-monotonic, we can consider negative attribute also. Access policy may be open. Access policy may be openly attached with the ciphertext, it may be partially hidden, or it may be fully hidden. Okay, so in fully hidden, that we can protect it from user, we can protect it to protect the user privacy from leakage, because person existing in the system can identify the user based on the access policy. So this also provide privacy protection. Length of the ciphertext may be fixed or variable. It in fixed length ciphertext, length of the ciphertext is independent of the number of attributes, while in variable length it varies based on the number of attributes in the access policy. Architecture may be centralized, decentralized, or hierarchical. In centralized, there is only single authority to distribute the task of central authority. Decentralized and hierarchical architecture are used. Okay, so features basically that provide efficiency, that may increase efficiency based on length of the ciphertext, to minimize the length of the ciphertext, to reduce the cost of encryption per data file, and to minimize the secret share generation cost. And revocability is also required to revoke a particular attribute from the user, or to revoke a user completely. Key delegation is a feature that is used to delegate his or rights to another user in case of absence. Okay, so it may be partially or it may be fully attribute key delegation. Limited further key delegation is basically when I delegate my key to someone, then the delegate who has received my key should be able to access my data, for a specific period, and should not be allowed to further delegate, or should be or if it is allowed, then there should be limited number of further delegation. And privacy is basically hidden access structure, so no one can, so the user's privacy should not be revealed. Okay, so mainly difference between single authority CPAB and MA CPAB is basically there is single authority, single central authority. In MA there are more than one authorities. So there is single authority, so definitely it's fully trusted, while in multi-authority we use decentralized architecture, and we cannot assume that all authorities are uh, honest. Okay, so there is issue of key escrow. Key escrow is basically here, as CA generates the secret key for everyone, so CA is able to access the entire data of every user. In case of CA failure, then system will goes down. While in multi-authority, the issue of key escrow is removed, and but there is issue of there is mainly there exists trust issue, because we cannot assume that all authorities are honest. So this CPAB technique is based on bilinear pairing, and uh, we require every user should have a set of attributes based on their role in the organization. For example, university professor may has department designation, basic salary, like that. And attribute in universe is universal set of attributes which contains all set of attributes of all the users, and access policy is generated using the set of attributes and logic gates. It may be AND gate, OR gate, NOT gate, and threshold gate. Threshold gate is like one of three, so there is by default an OR gate. This is combination of multiple OR gates. So main functions of CPAB, original CPAB technique is setup, encrypt, regeneration, and decrypt. In setup operation, it generates the master secret key and global public key. Master secret key and global, here alpha and beta are the random integers, and G is the generator of bilinear group. Okay, so MSK is basically beta comma G to the power alpha, and this is global public key. To encrypt, here mainly we use the concepts of secret share generation and secret share reconstruction to set for the access policy. Okay, so for root node, we choose a random secret, and this secret is divided into its child nodes, and for each and every leaf node, that the all leaf nodes are basically attributes. For each and every leaf nodes, basically the top secret share is divided, and at the time of decryption, these components are combined to determine the original secret value. Okay, so at the time of key generation, here each user has key in two component. One is attribute independent component, another one is attribute dependent component. Attribute dependent component is generated using the using the set of attributes. For each and every attribute of the user, we generate two component. Okay, one component is basically this is attribute independent component. There is nothing related to set of attributes of the user, and this is having the generated using the set of attributes of the user. To decrypt the ciphertext, again here we perform secret share reconstruction process. Okay, so if user's set of attributes satisfy the access policy, then the secret value will be generated, and we can decrypt the message of this ciphertext. Here ciphertext, again ciphertext have access policy T, and here again the ciphertext has two component, attribute independent component and attribute dependent component, that is dependent on the attributes of the access policy. Okay, so if user's attribute satisfied, then this component will be deleted and user can get the original message M. Okay, so this is totally dependent on the bilinear pairing operation. Here we perform division, multiplication, addition operation. This is just related to just like a elliptic cryptography. Okay, so now I am going to present some algorithms that we can add with blockchain technology for enhancing the security and enhancing the security and privacy issues. So first one is CPAB based content sharing scheme to generate integrated ciphertext for hierarchical content. Hierarchical content basically, if in a system there are three users, U1, U2 and U3. U1 user has attribute A1 and A2, U2 has attribute A1, A2, A3, and U3 has attribute A1, A2, A3 and A4. Okay, so user 1 has two attributes, user 2 has three attributes, and they are having common, and user 4 has four attributes. Okay, so user 1 will be able to access file F1, user 2 will be able to access F1, F2
two files, and user 3 will be able to access F1, F2, F3, three files. So in normal CPABE, traditional CPABE, we have to perform 3 encryption operation. Okay, using this technique, we will perform only single encryption operations for hierarchical files. Okay, here I have taken an example of data generated by the sensing devices, and this data is encrypted using the CPAB technique. Okay, these are the users. This data is generated encrypted using CPA. Here this data SD1, SD2, SDK. This first user will be able to data from 1 to K. Second user will be able to data from 1 to N. Okay, so here we are performing only single encryption operation, and only single ciphertext will be generated for N hierarchical content. Okay, so basically we are reducing the encryption and decryption. We are highly reducing the encryption and decryption cost, and we are also reducing the storage cost, because rather than generating the 3 different ciphertexts, we will generate only single ciphertext. So encryption cost is 48% of encryption cost of original CPAB, and decryption cost is 46% of traditional CPAB. Another is fully flexible key delegation mechanism for delegating his rights in fine-grained access manner. So basically, at the time of key delegation, if we delegate if we delegate key based on the set of attributes, so suppose if I am delegating my 3 attributes to someone, then based on these 3 attributes, that user will be able to my entire content that can be accessed through these 3 attributes. Okay, so it should be there should be restriction that I am given my key, but that person should be able to access only a particular file, not all the files. Okay, so there should be specific content delegation, specific write delegation such as read, write, and update. It should support limits on number of further delegation. Okay, that suppose that person is also not available to access my data, and then if he or she wants to further delegate, then there should be limit on that. It should support limit on accessing delegated content. Delegatee should be able to access the content 1 or 2 times, and support delegatee revocation after completion of my work. Then delegatee should be revoked from the system. Okay, so this is the system model. Here data user provide his identity and set of attribute to the central authority. Central authority generate the key in 2 component. One is attribute dependent, and other one is attribute independent. Attribute independent component is stored in a trace list. This is the data structure: trace list, capability list, and revocation list. In revocation list, we maintain the list of revoked user or revoked attributes, and capability list basically which content, which file it may access, how many times it may perform read operation on that, how many times it may perform write operation on that, and how many times it can perform update operation on that. And trace list is basically with this particular user is original user, or it has received the key from some another user, and its attribute independent component, and its maximum it's a delegation count, how many times it can further delegate. So central authority generate the key in 2 component. Attribute independent component is directly stored in the trace list, and attribute dependent component, second part of the secret key, is issued to the user. Okay, so here user doesn't has complete key. User has only second component of the key, that is attribute dependent part. Okay, and another entity we have introduced here, that is trusted mediator. Trusted mediator will be able to access the trace list and capability list. It will not be able to access the data, because in trace list only attribute component of the key is there. Okay, so trusted the system is secure from this third party. To delegate the key, data user takes identity of the delegatee and based on that, how many attributes it want to delegate. Based on that, it generates second component of secret key and provide to the delegatee, and a transformation key is provided to the trusted mediator. Trusted mediator check this user is allowed to further delegate or not. If user is allowed, then respective entry is done in TL and CL, and for this delegatee, first component of the secret key is generated and stored in the trace list. At the time of accessing the data user provide his or set of attributes and the content that it want to access. Trusted mediator check this particular user is allowed to access or not. If it is allowed, then intermediate ciphertext will be provided to this user, because first key is with the TL. Okay, so intermediated ciphertext will be provided to the user, and from the second component of the ciphertext, second component of the key, it will be able to access the data. Okay, so here basically we are providing the different access rights for delegation. We are different access rights for delegation is we are providing specific content delegation, specific number of further delegation, specific accessing and revocation. Okay, so this scheme also reduces the cost of encryption and decryption. Only the cost of key delegation is quite large, because we have to write the data in TL, CL and revocation list. Okay, so this scheme support fully flexible key delegation mechanism, efficient in term of encryption and decryption operation, specific content delegation, access rights delegation such as read, write and update, and limited access of delegated content. Okay, so this scheme require only 9.6% cost of encryption and 46 cost of decryption operation as compared to basic delegation, and two more delegation schemes provided by different researchers. And now these two techniques are related to single authority CPAB. Now to reduce the overhead of single authority, schemes move to multi authority CPAB. So here basically there is a central authority and more than one attribute authority. So task of central authority is divided into these attribute authority. Okay, so the main thing, this scheme enhances the security, improves efficiency and reduce storage requirement. Here now we have one thing is that we cannot trust that all attribute authorities are honest. To protect this, we have divided the user key into two components. One key is given by the central authority and another key will be provided by the, so here SKCADC is secret key of data consumer provided by the CA, secret key of data consumer provided by the attribute authority. So basically user received the key from different authorities based on the attributes and a central authority. Okay, suppose there are 10 attributes and 10 attributes in the system and 5 attribute authorities. Okay, so each authority is authorized to manage two different attributes. Okay, so it will receive in the keys from attribute authorities and central authority. Okay, so this key is basically a component. This key is generated by the set of attributes of the user. So here, if any attribute authority illegally generate the key for a user that is not having the attribute, in that case user will not be able to access the data, because for decryption both these two keys are required, but this key, the set of attributes in this key will be different from the set of attributes generated by the attribute authorities. So here we are overcoming in this trust issue. Okay, so this model is secure from unauthorized or untrusted authorities. Okay, the scheme is generated in such a way that it reduces the cost of encryption and decryption operation. This scheme is key escrow free. Key escrow free is basically system. There is multiple authorities and CA will not be able to access the data of the user, because CA provide only one part of the key, and other attribute authorities provide their secret key. To decrypt the data, both keys are required. So we remove the problem of key escrow. Corrupt resistant. If any corrupt authority illegally generate the key for a user that is not having that attribute, in that case, that user will not be able to access the data. Generate constant length ciphertext, that is independent the number of that is independent on the number of attributes, so it reduces the storage cost, and it reduces the cost of encryption and decryption operation. Also, it support hidden access structure. So basically it protect it maintain the user privacy. From the access policy, no one can identify the users who will be able to access the data. This scheme is efficient in terms of encryption and decryption operation. This is secure against corrupt attribute authorities. Okay, so this proposed scheme is basically reducing the encryption 8% encryption cost and 48% decryption cost. Next is also MACPAB scheme. In this scheme, we, in case of corrupt authority, we can revoke an attribute authority, or we can, in case of overloaded attribute authority, we can revoke some attribute from that authority and we reassign attribute to another authority. So basically we can maintain we can maintain a system where each attribute having the same number of attributes, no attribute authority is overloaded. So in case of so this techniques basically implement partial attribute revocation from attribute authority, complete authority revocation in case of corrupt attribute authority, implement fully hidden non-monotonic access structure. In non-monotonic, access policy also consists negative attributes such as no students can access this particular data, so we can add negation with attribute student. Improve efficiency. Okay, so and we also perform dynamic attribute reassignment. We revoke an attribute from a particular attribute authority and reassign this attribute to another attribute authority. Okay, so here this is central authority. These are attribute authorities. Here again, the same concept is used. This each user receives two keys, one from central authority and others from attribute authority. At the time of decryption, the both keys are required. So corrupt illegally access will not be there. In this is the system model or flow diagram of the encryption and decryption process. Here central authority generate global public key. Global public key is used by the data owner or data user, and secret key is generated by the CA and provided to the user. Secret key generated by the attribute authorities are also provided to the users. Data owner perform encryption operation and store the data on the server, and based on their set of attributes and secret keys, user will be able to decrypt the ciphertext if his or attribute satisfy the access policy. So the main thing is revocation of attributes from attribute authority or complete authority revocation. Here central authority to revoke an attribute. So basically we can see here, to encrypt the data, global public key is used, ciphertext policy is used. Based on the ciphertext policy, ciphertext is generated, or in ciphertext policy attributes are used. So if we are revoking an attribute, so definitely we have to generate update for ciphertext also for that particular attribute. Okay, so in that, here different updates for ciphertext and updates for users keys and updates for attribute authorities keys, these will be generated. So so basically to revoke an attribute, central authority generate update for keys of attribute authority managing particular attribute. Okay, and that attribute authority generate the update for key for that particular attribute for the users having that attribute. Okay, same for the ciphertext. Central authority will generate the update for ciphertext for particular attribute, and public key of attribute authorities are used for encryption. So attribute authority will also generate update for ciphertext for that particular attribute. Okay, suppose here AID key is basically ID of attribute authority K. Okay, so suppose attribute authority K is handling that attribute, so this will generate the update for that particular ciphertext. Using in these updates, data owner will update the ciphertext, then users will be able to access the ciphertext from the updated key. Okay, to this is the process of revoking an attribute. If we have to revoke an entire authority, in that case we have to revoke every attribute one by one, and we have to reassign these attribute to another authority. In that case we will generate the, again we need to generate the updates for attribute authority. Okay, now attribute revocation from the user. Okay, for like attribute authority, if we are revoking the attribute from the user, in that case we need to generate update for ciphertext, we need to generate update for keys of the attribute authority, keys of the users, in that, so that that particular user will not be able to access the data whose attribute has been revoked, and other user in the system will update their keys so that they can access the data. Okay, the scheme is designed in such a way to improve the efficiency of encryption and decryption operation. This is efficient, key escrow free, support non-monotonic access structure, and users anonymity is maintained basically by using the fully hidden access structure. This scheme support attribute authority revocation, and encryption cost is reduced by 24% and decryption cost is reduced by 42%. Okay, so these are the schemes, CPAB based on single authority and multiple authority. Okay, another thing that we can do to improve the efficiency is basically we can change the secret sharing scheme. Okay, here I have taken the secret sharing scheme. Yes. Here I have taken the Lagrange coefficient for secret sharing. We can also use counting based secret sharing scheme. Okay, so in this is counting based secret sharing scheme for matrix manipulation. What we can do here, we can here in this scheme we can generate large number of shares for secret value. In the previous in all the work that I have shown, we are taking a large value for generating the secret share. Okay, here from a small small value we can generate large number of shares. What we are doing here, a secret value is converted into hex and then into binary. Okay, based on the binary we are taking we are generating a matrix of n cross n. Suppose if there are n bits, then we are generating a matrix of n cross n. Okay, so the original value, suppose as first bit is basically the bits in the original secrets are present in the diagonal. Okay, and so basically we are generating so many shares here. For example, so we can see here if hash is 0, then number of shares will be, and number hash value is 0. So from 0 0 0 0 0, how many bits we have to change a bit at a time. Okay, so here we can change 1. Suppose integer value is 4, then it will be 1 0 0. So the shares that we can generate 1 1 0 1 0 1 and 1 1 1. We can generate only 3 shares. Okay, and at the time of reconstruction, what we do, we add the shares and we reconstruct the value. So from in this technique, we are basically converting into a matrix. So if the length of share is 6 bit, then there will be 36 shares. And previously Gutta provided a scheme. Okay, in their scheme there will be 6 shares in 1 bit method. In 2 bit method we can simultaneously change 2 bit. Okay, so for addition, if we are taking 3 shares, if we require 3 shares, and in addition, if we are getting 3, and we are getting 3, 3, 3, then this will be value 1, 1, 1. If we are getting the original value, then it means we are correctly combining the shares. Otherwise there is if otherwise the attributes are different from the user, or user is not having that particular attribute. Okay, so in this scheme number of shares has been increased. Okay, yeah. In 2 bits there will be 666 shares. Okay, like this there are, suppose in, if the value is 111, suppose the value is 7, then normally we cannot generate any share. While in our scheme, because we are using matrix of 6 cross 6, we are using matrix of n cross n, we can generate a lot of shares, so there will be no error cases. See here, this value is 1f. Okay, and 1f, it will be all 11111. Okay, there in their scheme we are not able to generate any secret. While in this matrix based scheme, in 1 bit method 31 shares can be generated. In 2 bit method 496 shares can be generated. Okay, so so the cost of secret share generation can be reduced using this technique. Okay, so here number of shares will be n cross n minus n1. N1 is the number of bits required to present the number. So basically where n is the number of digits in secret key, and n1 is the number of n1 is the number of ones in the secret key. Okay, so if already all bits are having 1, so we will not be able to generate any share. Okay, so this scheme is practical, simple, and more applicable. It improves efficiency, security. Uh, I am talking about the overall the work that I have presented, that improve the efficiency, security, user privacy, delegation functionality. Okay, provide corrupt resistance against MACPAB. It support attribute revocation from attribute authority in multi-authority CPAB scheme, efficient secret sharing scheme. And there is a scope to combine blockchain with CPAB technique that is more flexible and secure. And to use this technique, I have developed the code in Java, and basically I have developed my own library that is that is object oriented CPAB library. I have uploaded on GitHub, and I implemented in Java because it is flexible, applicable, portable, and provide efficient memory management, and also reduces the computational cost by adding multi-threading. Okay, so for that I have developed OMCPAB library, and it reduces the cost of encryption and decryption too much by using concept of multi-threading or parallel processing. Thanks. Any queries?
Any queries from the audience?
Madam, can you explain some application area where this attribute-based encryption plus blockchain can be used?
Yeah, sir, I have already searched on net. So basically, I am showing you. I am showing you.
because this FDP mainly focus on the blockchain
Yeah.
and its applications.
Yes.
If you can explain a little bit elaborated to our participants, so it will
Yes.
be.
So basically, they used they combine blockchain. Uh, this There are some references that I've collected. That I have collected. They used basically blockchain with accountable CPAB to protect the electronic document. Mainly, they worked on Bitcoin. Okay, and they supported key delegation mechanism using CPAB. If a malicious user share a decryption key illegally, it will be considered illegal. Similarly, if a central authority generates illegally decryption key, then user will not be able to access the data. So another one that I have, a lot of papers are there. They use for different. For They combine the technology for different application areas. They used for agriculture product traceability system. They combine CPAB and blockchain. So this is paper of security communication network and presented in 2022, and where we are using application. And basically, if app, if utility is sensitive, basically if the system is sensitive, then we should combine blockchain with any encryption. So for improving the efficiency, we can use AB encryption.
Okay.
Any other?
Because in AB, a lot of functionalities are there. It provides fine-grained access control. It supports key delegation. It supports revocability. That is not possible with other conventional cryptographic algorithms such as symmetric and public key cryptography like DSA. So recent algorithms are more efficient, more scalable, and applicable and secure.
So for
We
this
should come.
ABE also attribute-based encryption.
Yes, sir.
What is the this what you call? Then what is the advantage of this elliptic cryptography here?
Sir, this is totally based on the concept of elliptic cryptography.
Obviously, the blockchain also uses the ECC, elliptic cryptography.
Cryptography, yeah. So that's why they are compatible. We can easily combine them.
Okay. So what main concepts of ECC will be used in this attribute-based encryption?
For generating the keys?
Only for generate the key.
In the key, yes.
For signing and all?
For signing, we have to use for other algorithms.
Okay. Okay, participants, any other doubt? Yeah. Because this is a quite interesting area, because where researchers can focus on, and a lot of scope is there in this area. Participants and research scholars, if anyone is there who are working in this direction, you may ask some questions or you may get some research areas from madam, so that because madam also submitted her thesis, PhD thesis in the same area, and she was awarded PhD in the ABE also, attribute-based encryption. Madam, what is your title, madam? Thesis title?
Performance evaluation of CPAB algorithms.
So madam is can say one of expert in this area. So scholars, research scholars, if anyone is there, you may ask any doubt or clarification.
The security can be added everywhere.
Security is everywhere.